Okay, we've got a question here about a car moving on a roller coaster. So it's a question about types of energy. So first bit, what is the equation for kinetic energy? You should definitely know this, okay? Kinetic energy is half mv squared. Commit that to memory for eternity right now. Ke is half mv squared, okay? M is mass, V is velocity. Right, we're told that this car has a mass of 580 kilograms and we're told that GPE is gravitational potential energy, okay? It gains 39,000 joules, unit of energy is joules, from P to Q, okay? So the car rolls down here, then it rolls up again, it's got enough energy to make it all the way up to Q, and it gains, okay, that's height H from P to Q. So going from P to Q, it gains 39,000 joules of energy, okay? State the equation relating GPE, mass, gravitational field strength and height h. This is another equation which you need to commit to memory for eternity, okay? Gravitational potential energy is mgh. Tattoo that on your brain right now. Both of these equations need to be at your fingertips. Okay, so as it goes from P to Q, it gains 39,000 joules of energy, which is equal to the mass of the car times G, the gravitational field strength, which is a constant on Earth at 10 or sometimes 9.8, depending on what they want you to use in the exam. And H is the height. Okay, calculate the height H. And we have to take G, excuse me, as 10 in this case, newtons per kilogram. G is 9.81 more accurately. Sometimes they tell you to use 9.81, sometimes they tell you to use 9.8, sometimes they tell you to use 10, okay? In this case it's 10. Right, so we have to calculate H and we've been given the other three. Simple. So GPE is mgh. We want H, so we have to rearrange that to make H the subject. Therefore, H is equal to, we do that by taking the mg onto the other side by dividing both sides by mg. So we get GPE over mg. Simple. Stick in the numbers. Always rearrange the equation first, rather than putting the numbers in when the equation is in this form. It's annoying to have to rearrange it when the numbers are there. It's much easier to rearrange when the equation is in the form of letters or variables and put the numbers in at the very last step. So, stick it in your calculator. Well, actually, just write it down. 39000, that's GPE, divided by M times G. M is 580. Oh, I should say that GPE, it has to be in units of joules, which it is. Sometimes they might give you a GPE or a kinetic energy or some form of energy in kilojoules. You would have to multiply by 1,000 to convert to joules first, but this is already in joules, so that's what we want. The mass has to be in kilograms, it's already in kilograms, that's fine, and G is 10, okay? Therefore H is, stick that in your calculator and you get 6.7241 something something something. Now they don't tell you how many decimal places they want, so we have to make a sensible guess. 1 or 2 decimal places, it's up to you, either is fine. I'm going to go with 2. Let's say 6.72. Height would be in meters because we've got all these units correct. Height is in meters. And that's to 2 decimal places. Good. As always, a quick check, have we got a sensible answer? About 6.72 metres, about 7 metres for a car going up in height on a roller coaster. Yeah, that's sensible. It's probably correct. And it is correct. Okay. That was worth 3 marks, believe it or not. We'll take that. Okay. The car enters the pool of water at R. So from here it goes and splashes into the water and it comes to a halt at S. Okay? Describe how the total energy of the system is conserved as the car travels between R and S. Okay, this is worth 2 marks. Right. So, it's a question about energy conversion. So start off by saying that at the point R, the car has kinetic energy. Okay. Next. Right, you need to mention friction. So it's moving with some velocity at R and it comes to a halt at S. During that whole time, the car is doing work against friction. Okay? So the car does work against friction as it passes through the water. Through the water. Okay? Need to get that word in there. Alright? Okay, so energy cannot be created or destroyed, it's converted from one form to another. So let's say where the energy is gone. So the kinetic energy is converted to, right, I think the most important one is to say it's converted to thermal energy of the water. It's doing work against friction as it moves through the water, so it heats the water up a little bit. So K is converted to thermal energy of the water. Okay. Now there are other things you can say as well. I think, like I say, I think that's the most important one. What else can you say? Well, it's going to be a splash, isn't there? Which means some of the water is going to go up here. So water has mass and it's increasing in height. So the water is gaining gravitational potential energy. So you could also say GPE of the water. Okay. The splash moves as well. So that's water which has mass moving at some velocity. So the water will have kinetic energy. Also, it's going to make a noise, isn't it? So that's sound energy. And that's it. You'll definitely get the 2 marks if you put that. Now, the question said, describe how the total energy of the system is conserved as the car travels between R and S. I don't like that, the way they've put that, because this isn't really an enclosed system. It's surrounded by air. And if the kinetic energy of the car has been converted to sound energy, which it definitely is in reality, okay, the sound energy is not part of an enclosed system. Do you see what I'm saying? So technically, you shouldn't really say sound energy if you're answering the question they've asked, which is the energy of this system, and the water is part of the system, but I don't think the surrounding air is. So I don't like the question. It's not a great question, okay? It would have been better if they'd said, describe the energy changes as the car moves from R and comes to a halt at S. Then sound energy is definitely an important one to mention, okay? So let's hope in the real thing, in the exam, they word the question better. And then you should definitely say thermal energy of water and sound energy, okay? And the GP of the water and the KE of the water, they're less important, but there's no harm in mentioning them. Because eventually, you know, the splash comes down again and the GP is reconverted into thermal energy or sound or whatever. And the water eventually comes to a standstill, so it doesn't have any kinetic energy. So those two, in the long term, are gone. In the exam, put thermal energy of water and sound energy. Okay, they're the important ones. And mention the word friction. Good, and that's it. There we go.